Hi everybody, so I'm John Young from TSG, and what I'm going to do is give you a brief overview to the background to BDD, Behaviour Driven Development, and its relationship with extreme programming and test driven development. And in this background, I'm going to give you a little bit of a overview of how we use user stories to generate tests and the way in which TDD has evolved to have to turn into what we now have as behaviour driven development. So I'm going to show you a diagram explaining test-driven development. What a lot of people don't always realize is TDD is actually a design technique more than it is a test technique, but it has as a byproduct a set of automated unit tests. The basic idea behind the method is when you're looking at features and the technical implementation of features, think of a test to verify the feature, create that test and automate it, execute it, and the first time around that test will fail because you haven't actually written any code yet. Then write enough code to make that test pass, and then think of another test. Create that, automate it, execute it, run that, it fails, and then create some more code, just enough to make sure that both the first and the second test pass, and then repeat this process as many times as is necessary for you to verify the behavior of the technical implementation of the features that are implied by the stories. As we're going through these iterations, these cycles of designing tests, constructing them and running them and fixing the code, we get the opportunity to refactor or redesign and tidy up the code or the tests or the design to keep it consistent and to keep it easier to understand and easier to maintain. One of the downsides to extreme programming in TDD is it's seen as a development activity. So there is a tendency that we focus on the verification of the technical implementation of the features, and we don't always validate that the features are actually what are needed to implement the stories and add business value. So over time, the TDD framework's been extended. So acceptance test-driven development is an extension of TDD. So the assumption around ATDD is that you've got a test-driven development framework in place and it's working. And what we can now do is extend the process, so we can, rather than just have a development activity going on, we have a whole team process where in these 4 stages, in discussion, what we can do is discuss the acceptance criteria, either that have already been written with the stories, or as the team discuss the stories, new ones we need, or rewording or rephrasing the existing acceptance criteria. And in the process of discussing the stories, we start to discuss the features and the acceptance tests that we think are appropriate. So we can distill those acceptance criteria into tests, and we can make sure that we write those tests and articulate those tests in a format that is friendly to a framework for automation. So if we've got our acceptance criteria converted into tests, and those tests are more easily elaborated and understood by the designing and development side of the process, we can then allow the development, the TDD process, to design a solution that's focused on the acceptance criteria rather than in traditional development where things happen the other way around. So we can extend the acceptance criteria and elaborate them into stories, into the story acceptance criteria into tests, distill them into a framework, develop the code, hook the test together, and execute both the acceptance test-driven tests and the test-driven development tests. So the TDD tests and the ATDD tests are all run until they pass. And at that point, we've then got a story we can demonstrate to our stakeholders and our testers. And then we can use exploratory testing to look for any gaps in the acceptance criteria. So if we spot problems with the acceptance criteria or extra things that we need, we can then go through another cycle of ATDD to create new acceptance criteria, create the test, distill them, and repeat this as many iterations we need to be satisfied that we have stories that meet our acceptance criteria and are fit for purpose. So that validation process becomes very valuable. But because it's a validation process, we need to look at the acceptance criteria of the stories as a way of driving things forward. So it's important that the acceptance criteria are aligned to the business value that the story is intended to deliver. So here we've got a simple user story related to a 10-pin bowling game. So as a 10-pin bowler, I want to keep score of my game. And the business value here is that I can enjoy interacting with the players. I don't have to concentrate on the scoring rules. So some of the important features we need here are associated with the acceptance criteria. So the acceptance criteria are quite specifically associated with the scoring rules of the game. But we're not worrying about the mechanics of how the ball is rolled or how the scores are actually being calculated. Behavior-driven development is an extension and a variation of acceptance test-driven development. I mean, you could just say, as we've got on this slide here, what we're doing is just changing the word test to behavior. But the problem people have with tests is they tend to be familiar with test scripts and all their steps and their detail. So the idea of behavior-driven development is to concentrate on what it is in terms of functional and non-functional behavior that we want the story to deliver, and not get sidetracked by trying to describe the solution. So that's what we mean by an outside-in approach. We describe the acceptance tests in terms of the behavior we want, and we don't get sidetracked, and we don't try to anticipate too much of the technical implementation of those features. But by creating acceptance test criteria, if we use a consistent format, if we use scenarios using given, when, then, which Tom's going to explain in more detail later on in the webinar, what we get is a consistent format and a way of expressing these scenarios which is clear and easily understandable and much easier to translate then into code. The frameworks that we then distill the tests into are going to be dependent on the technologies being used, and Tom's going to explain some more detail on that later on. But the aim of having acceptance criteria turned into test scenarios using business language is that this common or business or ubiquitous language is using terminology that's more business related and business friendly, and it allows the whole team to spot not just technical risks but business risks associated with the implementation of the stories and the stories features. So here we've got an example of some BDD scenarios that are based on that previous user story, both related to part of playing a 10-pin bowling game. So the first scenario is describing what would happen in the early stages of the game if we haven't knocked any pins over. And the second scenario is describing what would happen towards the end of a game if we've not knocked any pins down. So what is often referred to as a gutter game. We've rolled the ball and it's gone through the gutter of the alley and it's not actually hit any pins. But in each case, we're describing the given prerequisite, what's happened, and the then description describing exactly what behavior we expect. But we're not describing any of the detail of the implementation, how the design should be put together. We're totally concentrating on the business needs. These scenarios are also effectively requirement specifications, and they can be used to describe not just but now, but for the future, what it is we want and the best ways in which we can test it. So the difference between a test scenario in BDD compared with a test scenario at TDD is the level of detail we work at. So if you notice, we've got two different scenarios here. On the right, we've got a BDD scenario, behavior-based, and it's very, very generic. It's, in this case, it's not the 10-pin bowling, but we're describing searching for TSG using Google. And what we're basically saying is when we search for TSG on Google, we expect to see a TSG in the results, but we're not specifying any fields, we're not specifying any methods by which we run the search. By comparison, the TDD test is step-by-step explicit, and it anticipates the design, or it's based on the design that we're already aware of. So it's working step by step, and it's looking at field and implementation specific characteristics that we're searching or looking for. The problem we have in writing a TDD test is it's very hard to describe this test until we know what the design is. If in fact we write these tests before we know the design, what we're creating are design constraints which make things difficult for the developers. The other downside is these tests are quite brittle. If the design implementation changes, then we have to change the TDD tests. Whereas the BDD tests, because they are outside in, because they're just using business language, they've got a longer shelf life, they are more resilient to change, and they should focus on what the business wants, unless, of course, the acceptance criteria themselves change. So this is just a high-level description of the methodologies. What I'm going to do now is hand you over to Tom, and Tom's going to take you through the mechanics of this process in a lot more detail. Thanks, everyone.
Okay, thanks, John. Hopefully everyone can see my screen. Okay, so I'm going to carry on where John's just finished, and I'm going to move into the sort of mechanics of it and give you an example of BDD and using it in conjunction with test automation. So John's just sort of explained what BDD is. So why BDD? Well, it's a ubiquitous language that everyone can understand. So the stakeholders, developers, testers can understand those requirements, those features of the system, and what we're expected to do, what the outcomes are. And it's written in a language that everyone can understand, a very natural language. So it's acting as very much a collaboration tool. It also documents the way that we want the system to be developed. So as John said, our features, which we document in BDD, really are our requirement specification and act as our acceptance criteria when we start automating our tests and running them. Now, one of the great things about BDD is that it uses this language, which we're going to talk about in a moment, called Gherkin, which is a structured syntax, but still very natural language, English-like, very easy to understand. But because it's structured, it means we can automate it. We can associate code with it, and this is the power of BDD. So the BDD process really sits, it's on Agile. It's an extension of Agile. We've still got the three amigos: dev, test, business, stakeholders. Out of Agile, we're producing user stories. And the idea is that we can start with that user story and we can elaborate that user story to define the features that are going to provide that user story. And then we can break those features down into scenarios which are used to prove the feature. So you can think of scenarios as our test cases, if you like. And all of this is done in a nice, easy to understand English-like language. Now, BDD itself really is a mindset to concept. It's not a tool in its own right. So there are a number of different tools that we can use. So there's a few basic ingredients we need. We need some kind of IDE to write code, because that's what we're going to do behind these features. Behind the BDD, we are actually going to create some test automation. So we need an IDE, some kind of development environment, and we might be using Eclipse, Visual Development Studio, Sharp Develop, IntelliJ. So in the example I'm going to use Microsoft Development Studio in this case. Then our BDD interpreter, one of the most common, or the first, was Cucumber. I'm going to be using SpecFlow, and SpecFlow is actually just a .NET version of Cucumber, and it's available open source. Or you might be using Serenity, you might be using JBehave. And we'll see how this works on the next slide, but our interpreter is there to interpret our feature files and then call the associated test automation. So we need an automation tool. It's all around test automation, and that could be anything we wanted. It could be Selenium, it could be Ranorex, could be LeanFT, could be White from TestStack, could be Appium. So in this example, I'm going to be using Selenium WebDriver. And then finally, we probably want to make use of a testing framework, because we want to create results, we want to report passes, we want to report fails, we want to organize our testing. So we can use any of the available common testing frameworks, but in this example, because I'm using .NET within Visual Development Studio, I'm going to be using NUnit. I could have used MS Test, but NUnit just provides a few extra features, a little bit more flexibility for what I want to do. Okay, so the tool stack you choose is very dependent on the technology that you are testing and the experience of your testers. Okay, so how does this work? Well, the idea of BDD is that we are going to document the system, and we document the system in a language called Gherkin. And Gherkin is, as I say, a very sort of natural language, very easy to understand, and we just write that as plain text in text files. and these files are called feature files. So a feature file is simply a text file where we document the system. We write our features and we break those down into scenarios that will prove the feature. We then need an interpreter, which might be Cucumber, JBehave, SpecFlow, and what that does is it parses those text files, those features, and it calls our associated automation code. So our WebDriver tests or our RANRX tests or whatever they may be. So I've mentioned that feature files are written in Gherkin. So Gherkin is an English-like or a natural language-like syntax. It's actually available in 60 different languages, so there's plenty to choose from. And it's the syntax we use to describe the behavior of our system and the outcomes. So Cucumber and SpecFlow are just interpreters that parse the Gherkin in these text files, these feature files. Okay, feature files, as I say, a feature file is a text file. Each one of these files has one feature. So one feature per feature file. So the feature is just one of the features that are going to be provided by our user story. So for example, I might have a feature managing users. So as part of this feature, administrators on the system can manage users. Now to prove that feature, we then start writing scenarios. And scenarios are equivalent to our test cases. The scenarios are there to prove the features. Scenarios are normally 3 to 5 steps, and these steps can be a given. Some of these, this is optional, which would describe an initial context or a prerequisite. We then describe an event. When I do this, we then describe an outcome. Then this happens. So some of the basic keywords we've just talked about there, we've got a feature. And a feature, there's one feature per feature file. Feature files are just text files. The feature is then proven using scenarios, and there may be one or there may be more than one scenarios. Each scenario has steps. Given, when, then, and we can also have and but. So let's just look at a very simple scenario. So I've got a feature file. Within my feature file, I've got a scenario. So again, using this Gherkin syntax, here's one of the keywords, scenario. The scenario is adding a new user. Given, I'm logged in as an administrator. When I add a new user to the system, then the user can log in. So here we're just describing the behavior and the outcome that would prove that scenario. Now we can make these more complex using the keywords but and. So here's another example here. This is a scenario. Remember, a scenario is really equivalent to a test scenario. Forgotten PIN number. Given that I have £500 in my bank account, so there's my prerequisite. When I attempt to withdraw £50, but I've forgotten my PIN, and I make more than 3 invalid attempts, then, so this is the outcome, the cash point will not allow the withdrawal and the cash point keeps my card. Okay, so this is what our feature files look like as we start building them up. Remember, a feature file is just a text file that contains a single feature. That feature is then broken down into scenarios, or we provide scenarios that would prove that feature. So we might have a scenario for adding a new user, another scenario for deleting a user. So let's actually have a look at this, what this looks like, the mechanics of this. Now, as I mentioned earlier, I'm going to be using Microsoft Visual Studio. I'm going to be using NUnit as my test framework, and I am going to be using Selenium WebDriver with C# bindings as my automation tool. And the BDD is going to be provided using SpecFlow, which is the .NET version really of what's based on Cucumber. Okay, so I'm just going to move over to Visual Studio. Okay, so a couple of things in Visual Studio that I've set up already. First of all, if I go off the tools, and if I go to extensions and updates, then there is an extension which I have installed already for SpecFlow. So I've installed this SpecFlow extension, which is quite useful because it allows me to create feature files and it recognizes that file type. So that's the first thing. I've then created a new solution and I've added some references. If I right click on here and we go to the NuGet packages, okay, so I've added in NUnit. Remember, I'm using WebDriver, so I've added in WebDriver and also the Chrome driver for driving the Chrome browser, and finally the SpecFlow libraries as well. So that's already been set up, and you can see that in my references here: NUnit, SpecFlow, and WebDriver. Okay, so the example I'm going to do, I'm going to take a very simple web example, which is why I'm using WebDriver in this case. I've got a website here, and part of this is that I can log into this website. And when I log in as an administrator, then I can do things like add records, edit records, remove records, list records, and do other things. So let's just take this as a part of the system being developed that I want to document. So first of all, in my project, I'm going to add a couple of folders to store our features and also our code files. So I'm going to right click on the project and I'm just going to add in a new folder, and this is going to store my feature files. And then I'm just going to add another folder which is going to contain my code bindings, which we'll look at in a moment. All right, so let's create our first feature file. I'm just going to right click on features, add a new item to my project. And because I've got this SpecFlow extension installed, everything I'm using here is open source, by the way. Here's the SpecFlow feature file. We can see we've got that as a template. Now, as I mentioned earlier, a feature file is just a text file, but it has the extension .feature. Okay, so let's give this feature a name. And click Add. Now what SpecFlow does for me automatically is it gives me a template for the feature and also for a scenario. So here we've got the feature name, and under it we can provide a description. Which will appear in our reporting. Now remember, we can only have one feature per feature file. So this is the feature. I can then create one or many scenarios to prove this feature. And there's a tag here at the moment, but I'm going to delete that and we'll talk about that afterwards. And you can see it's given a template here for a scenario. So let's create a scenario. Let's call this admin login, which is what we just looked at on the website. And you can see it's given us the structure. So these are our Gherkin keywords: given, when, then. So let's just write this, as I say, just in English, plain English. Given that I am on the Edgewords website, so there's my prerequisite. I'm not going to have an and in this case, so we can remove that. So here's my behavior. Let me describe the behavior. When I log in as an administrator, and then is the outcome. So when I log in as an administrator, then I see the full admin list of options. Okay, so there's our first feature. We've created a feature file. We've given this feature a name and a description. And we've created our first scenario, admin login. and our scenario steps, given, when, then. Now remember, this is just a text file, but if I right-click on this, I can execute this under SpecFlow, because remember, SpecFlow is going to parse this text file and try and execute any associated code. If I go over to the left into the Test Explorer, we can see that this has not executed because at the moment there are no matching step definitions. We haven't written any code, so it can't do anything. So remember, in our Project Explorer over on the right-hand side, here are my features. I've just created a feature. What I now need to do is create some code that will actually execute and prove this scenario. Now, very nicely in SpecFlow, we can get it to create most of the code for us automatically. So if I right-click, we can say, let's generate the step definitions. So it's recognized that there are 3 scenario steps that it would need to create definitions for in code. And it asks us what it wants to call the class that we're going to create, which is going to be our code file. And we can copy these to the clipboard, or we can generate the file in its entirety. So I'm going to hit generate, and it's asking us where we want to put this. And I'm going to put it in the code bindings folder. Remember, in our project, we created this folder at the beginning. So code bindings, that's great. And click save. Oh, I didn't select the folder. So you can see it over here. Let me just drag it into the code bindings folder. That's better. Right, so we've now got 2 files. We've got our feature, which is just a text file, and then we've got a C# object class here. And this contains our step definition. So note this, here's the given, when, then. So we've got 3 methods in here that will match up to our 3 scenario steps. But currently we haven't put any code in there. So again, if I try and execute this, SpecFlow realizes that there are step definitions. So you can see down on the bottom left, 1 or more step definitions are not implemented yet. So it says, right, you've created step definitions, but if we look at the step definitions, currently they all have a status of pending. There's no code. Right, so let's just have a closer look at these step definitions. Here are the step definitions, and below the step definition, directly preceding it, we've got a method, or a function if you like. So how is this working? Well, this is what the interpreter is doing. In our feature file, SpecFlow, when we execute our features, SpecFlow parses this, and it takes our scenario steps and it looks for a step definition that matches that string of text. So that's all it's doing, just string matching. So given that I am on the login page, it will then look in all our object classes for a method that matches that string of text. So in this case, here's our step definition, given that I am on the login page. As soon as it finds a match, it will then invoke the preceding method, which will have our automation code in. So this is why they're called code bindings. We've got this binding between scenario steps and step definitions, which belong in our code modules, if you like. Okay, so let's have a look at, come out of that. Let's have a look at how we can get this to work then. Here's my step definitions file. Okay, thanks, Jonathan. Okay, and in here, I'm going to use WebDriver. Now remember, you can use any automation tool that you've decided on using. In this case, I'm going to be using Selenium WebDriver. So I've already added the libraries as you saw at the beginning of this. So let's just import those libraries into this class, or reference them rather. So first of all, let's bring in Selenium. I'm going to use Chrome as my browser. So I also need, or I will need to instantiate the Chrome driver. And then finally, I'm going to be using NUnit as my automation framework, or my test framework rather. Okay, so just referencing a few libraries here that, remember, we've already referenced using NuGet. Here they are: WebDriver, SpecFlow, and NUnit. Just imported those NuGet packages. So let's take the first step. So if we go back to the feature, given that I am on the Edgewords website, so there's our prerequisite. We need to be on the Edgewords website. Here's the step definition. By the way, if I go back to this, you can always right-click on a scenario step and say, take me to the definition, and it will take the cursor to that point. So here it is. Here's the definition, that I am on the Edgewords website. So let's remove the pending. And in here, we will create the code to do that. So first of all, just at the beginning here, I just need a field to store my Chrome driver. Right, so let's go to our method. Here's our first method, or our first step definition. So first of all, let's instantiate our Chrome driver, which will open up Chrome. And the next thing we need to do is navigate to our URL. Okay, done. So 2 steps: launch Chrome and navigate to this URL. And that will provide our given statement, our prerequisite. So all we've done in here is actually create the code that will be bound to our scenario step. So again, if I run this now, right click, run SpecFlow scenarios. There we go. Chrome's been invoked and it's gone to our login page. However, the test hasn't executed fully because one or more step definitions are not implemented yet. The scenario can't report a pass or a fail because we haven't provided the code for all of the steps. So let's just go back into our code class here and let's complete the other 2. Now, to save me typing all this out, so I'm not the quickest typist, we will just copy and paste this in. So the next step is when I log in as an administrator. So this is our login. So you can see here I'm clicking the login link, I'm typing in the username, typing in the password, and then I'm clicking the submit button. The final part then is the then step, which is our outcome. Then I see the full admin list of options. So this is where I'm going to use NUnit to provide our pass or fail using an NUnit assert. And all I'm doing in this case is just checking that the add record link is displayed. If it is, then I know that I'm in as an administrator. And then finally, I've got driver.quit, which is just going to close the browser. In fact, what I'll do is I'll just leave that out, because then you'll see, leave the browser open, you'll see that we're on the correct page, hopefully. Okay, so I've now provided my 3 scenario step definitions, and I've completed my automated code in there, in this case just using Selenium WebDriver. Let's go back to our feature, right click, and run. There we go. We can see the login was successful. It should have checked that the add record link was there, and if it has, it's passed, which we can see. Here are our results. Okay, now there is obviously a lot more to this. Is a very, very simple introduction to BDD, in this case using SpecFlow, but there is a lot more to the Gherkin language. We can do all sorts of things with Gherkin. We can provide tables and examples. We can do things like reuse code, which obviously is important, integrate it into the page object model if we're using Selenium. Lots and lots of other things that we can do. So this is just a very simple example. So there's a couple of other things I'm just going to mention here. First of all, organization. So we can use, the Gherkin language allows us to use tags. So for example, I could put ignore next to a scenario if I didn't want a particular scenario to execute. And we can do these at the feature level or at the scenario level. So if I run it now, the test has been skipped, as you can see. We can also create our own tags for organizing our tests. So say this was a smoke test. I can define which scenarios are smoke tests. And again, if I just build the solution, because I'm using NUnit, these tags within Gherkin are actually converted to NUnit traits, and we can see that here. So we've got category smoke test, and that's because if I right click on here, I've put group by and I've changed the group by to traits. So these tags are converted to NUnit traits, and that allows me then to organize my testing. And with any of these tests, we can right click and we can add them to playlists as well, so we can create test suites, if you like, that we want to execute. Now with any of these tools, we probably want to start running this stuff from the command line at some point. If you're using continuous integration, something like Jenkins, then we want to be able to kick off executing all of our features through the command line, and that can be done pretty straightforwardly with any of these tools. Remember, I'm using SpecFlow here within Visual Studio and I'm using NUnit. So NUnit actually provides a runner, a command line runner, and when I build my Visual Studio solution, the output is a DLL, so I can just point to that DLL and execute it using the NUnit command line runner. So as an example here on my desktop, I've got a little batch file. If I open this, you can see all I'm doing is using the NUnit runner, NUnit3 console.exe, and I'm passing in the DLL, which is my compiled Visual Studio project. And if I run that, there we go. You can see it's actually executing those features. So we've got SpecFlow going through those feature files, parsing the features, calling the associated automated code. And at the end of this, because I'm using NUnit will actually produce a test result file as well, which is in XML format. And then I can use other tools to publish those results. Okay, so we'll just let that finish. Okay, so there are a few scenarios that are executed there. Now, when it comes to reporting, there are, again, lots of options. Depends on the technology stack that you are using. If you are using SpecFlow, the developers of SpecFlow also produce a paid version called SpecFlow Plus, which has got some really nice dynamic HTML reporting. But just to give you an example, there's another open source tool called Pickles to go with our Gherkin. And this can either be a command line tool, or you can use the version with a GUI, a user interface, which I'm just opening now. And in here, we can tell Pickles where our features are located. So remember, if I go back into... He's getting you hungry, yeah. I know. We got mocha, chai. You can have drinks with it as well. Okay, so if we go over into the Explorer here, remember my features are in this folder within the project. So all of our feature files will be organized in here. So I can tell Pickles where my feature files are located. I can tell it where I want my results to be generated. And remember, I've just executed some features and some scenarios using NUnit. So NUnit produces a results file, as I mentioned a few minutes ago, which is an XML file. So I can tell Pickles where the results file is from the last execution as well, and tell it that this is an NUnit3. You can see if I click on here, we can use any of the other testing frameworks, MS Test, XUnit, etc. And then we can say what kind of report we want. Well, we can have all of these if we want. So we could have a Word report, JSON, Excel, dynamic HTML. We click generate. It will then go and document all of our features for us, so we can make those available for everyone, all of our collaborative teams. And if I click open on the output folder, so here they are. We've got JSON, Word, dynamic HTML. If I open that, open up the index page, here are my features. So over on the left hand, I can click on the feature files, and within the feature files I can see the scenarios. So we've got a login, log out, Google search. And if I go right over to the right, we can see whether these scenarios passed or failed on the last run. There's even a show overview over here as well, so we can produce some nice pretty graphs. Okay, again, this is just an open source tool, Pickles, and again it can be run from the command line. So you can actually, you know, if you were using something like Jenkins, TeamCity, Bamboo, some kind of continuous integration tool, you could get it to kick off your automation, so run all your features, execute your features, produce the results as an end unit result, then invoke Pickles to parse that and turn it into, for example, dynamic HTML pages, which you could then publish for everyone to see.